So question, present a critical analysis of the theory of isostasy, or define the concept of isostasy and discuss the postulations of Airy and Pratt. The theory of isostasy postulates a system for the distribution of materials in the Earth's crust which conforms to and explains the observed gravity values. This theory was developed from gravity survey in the mountains of India about 1850. The result so that the actual force of gravity over the mountain range is considered less than it should be theoretically. The concept of isostasy means that a state of equilibrium or balance exists in the Earth's crust. More the boundary between crust and mantle is found deepest beneath large highest mountain ranges and shallower beneath regions of lower surface elevation. For example, the Moho is 80 km deep beneath mountain ranges, 40 km beneath the continental regions, and only 6 km beneath the ocean bottom. This means that the lithosphere is floating on the atmosphere with more massive portions reaching deeper to obtain needed buoyancy. It is simply as a massive block of ice will extend deeper into the water than is the next small ice cube, and the top side will be projecting into the air proportionately. If several blocks of wood of the same cross section but of differing height are floating in a water tank, each of the different blocks raises itself above the water level by an amount which is proportional to its length. A series of such blocks are in a state of hydrostatic equilibrium. Likewise, differences in density may also be responsible for such hydrostatic balance. Lighter density materials have a tendency to rise high. Thus, mountains which are composed of lighter materials than the surrounding lowland are high. Loss of material and thus weight by detention of landmass will upset the equilibrium of the landmass and cause it to rise until equilibrium is reached. If any additional weight is added to the landmass, such as a pile of volcanic material on the oceanic crust, it can make the crust subside, or accumulation of ice will also tend to depress the landmass. This process must involve some compensatory lateral flow of material at depth in the mantle. That is, there must be lateral flow from beneath the sinking column to under the rising column. Airy postulated that there is change in the density of rocks at depth in the Earth's interior, and that the upper lighter materials floats on the more denser part, which behaves like a fluid. The depth of this change varies from place to place. Under mountains, the depth is greater than under ocean or flat. In other words, the mountains have roots of lightweight materials which extends down into the lower, more dense mantle rocks. The lower density of the roots causes the observed gravity values measured in the mountain ranges to be lower than predicted theory. Pratt's theory differs from Airy's in that Pratt assumed that the boundary between the upper light material and the lower light dense rocks is at an uniform depth, called the depth of compensation. He further assumed that there are variations in the density of the lighter layer which are related to the elevation of the surface. Lighter material lies under the mountains and heavier materials under oceans. The weight of the columns of rocks extending from the surface up to the depth of compensation in different parts of the earth is thus the same. Gravitational studies different Studies offer no means of determining which of these theories is more nearly correct. It is possible that neither is absolutely correct, but evidence from other geological studies suggests that Pratt's theory comes closer to fitting all the facts we have. Seismic studies indicate that the more dense material underlies ocean basins than continents. These observations support Pratt's view of a connection between density and elevation. Heckman's view area postulates that columns of rocks are nearly the same in density, floating like blocks in a fluid. Pratt suggests that different segments of the Earth are of different densities, but that differences are compensated at a certain depth. A third hypothesis has been formulated by Heiskanen. He combines the views of both Airy and Pratt. It has been observed that rocks at sea level are more dense on average than those of the higher elevation, 2.76 gram per cubic centimeter at sea level down to 2.70 gram per cubic centimeter at elevation in high mountains. He assumed that this change continues downward, tending to make deeper rocks more dense than shallower ones in all sections of the Earth's crust. In addition, different sections are thought to have different densities and different lengths. Heiskanen's theory has the advantage of being based on actual knowledge of density variations that can be obtained by direct measurement and when it is applied to the observations we now have on the gravitational field, it yields very low and anomalies. On the basis of isostasy, many conclusions are drawn. If he supported that the height of Mount Everest is 9,000 meters, the lowest end Mount Everest be 9 inches deep in the substratum, that is about 81,000 meters deep. Again, the process of compensation does not take place swiftly. Compensation takes place slowly. As isostasy is distributed in a large, there is no evidence that any large area ever rises or subsides by hundreds or even by 5 meters as a result of the process of a compensation. Compensation is a very slow process. For example, the Gulf of Bothnia is rising every year by 1 centimeter during the Ice Age. Scandinavia, North America, etc. becomes heavy on account of thick layers of ice and consequently sinking out substratum on account of the onset of warm age. The ice melted and these areas become light again and are now rising slowly. Hence, compensation takes place in large areas. The activity is not local but regional.